got another PCB for repair. It's from a 1.5-ton Gree mini-split air conditioner outdoor unit. I've been trying to inspect it externally, but I haven't found any obvious issues so far, and I'm not quite sure what the exact problem might be. Now that I've opened this PCB and checked it a bit, today's fault seems entirely different. When I inspect the IPM, it appears to be perfectly fine. And let me show you. When I measure from positive to negative, it gives a value and then stabilizes, with no reading on other points, which is a good sign that the IPM is functioning well. Now, checking with reverse polarity, negative to positive and positive to negative, it shows a reading of 0.289. This suggests there's some issue, though not a short in the IPM. Something unusual is affecting its performance. Now let's check the IGBTs. I can see that we're getting voltages, and there's no short circuit in any of them. Moving on to the second IGBT. Here we see that one of the IGBTs is completely shorted, and it's causing the IPM to show disturbances. Because of this shorted IGBT, the entire PCB appears dead. On checking the rest of the diodes, they all seem fine, with only this one IGBT shorted. Next, I'll test the bridge rectifier. When I place the probes, it's showing 0 at one point, which isn't a good sign, but the other point is showing the correct reading. Since the first point is showing 0, there are two possibilities. After replacing the IGBT, I'll recheck the rectifier. If it's still faulty, then we'll go ahead and replace the bridge rectifier. When we inspect it physically, all the capacitors and components appear fine. I also checked both fuses, and they're both intact, with no issues present at this time. So, we've identified the fault, and now we'll see if replacing it fixes the PCB. After that, we'll recheck the bridge rectifier and verify all voltages again to ensure everything is functioning correctly. I've now removed the IGBT from the PCB, and I'll test it separately to show you. First, I'll explain the current position, as the IGBT wasn't showing accurate readings, and the rectifier was also faulty. Let's see if things have improved. I've set the multimeter to diode mode. Now, when I test the IPM by placing the positive probe on the positive and the negative on the negative, we'll see what value it shows. If the value initially goes high and then drops, it means that one side is working fine. Now let's reverse the polarity, placing the positive probe on the negative and the negative probe on the positive. Here, it's giving a reading of 0.643, whereas before the value was lower, which is a good sign. This means that our IPM is completely fine and there's no issue with it. Now I'm rechecking the IGBT and it's still showing the correct values, even when the polarity is reversed. There's no issue with the diodes either. They're all fine. Moving on to the rectifier, let's check its current status. I'll connect the positive side to the positive probe and the negative side to the negative probe. This shouldn't show any reading, as it's supposed to block the voltage in this direction. When I reverse the probes, placing the positive on the negative and the negative on the positive, it shows 0.831 voltage drop, which is correct. I checked other points, and they are also showing proper values, meaning everything else is in good condition. The issue lies with this IGBT. When I test it, it still shows the same voltage drop as it did when it was on the circuit, confirming that it's faulty. Replacing this IGBT should get the PCB back to working condition. Now, I'll replace the IGBT and see if the PCB powers on. As last time, even after connecting power, it didn't turn on. I've now replaced the IGBT, and the PCB is working properly. Let me show you the voltage readings with the multimeter attached, and the power is on as well. The PCB is switching on, and the light is now on in the standby position. When the PCB is connected to the communication system, the light blinks, indicating different states through various blink patterns. This confirms that the issue has been resolved and the PCB is functioning correctly. Today, we have the complete unit, so I installed the outdoor PCB and connected all the necessary wires. I also connected the indoor unit and the power is on. After setting the temperature to 16 degrees, we powered the unit on. You can see that the display turned on, and now we're testing how long it takes for the unit to start. As you can see, the outdoor fan started first, and after a short delay, the compressor also started. After a few seconds, the compressor turned on fully, and the unit is now working perfectly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.